This week we're going to finish off our course with a discussion on thermodynamics, and in particular looking at how we exchange energy between systems and between substances. So let's first talk about the first law of thermodynamics. So the first law states that there's really only two ways to change the internal energy of a system. The internal energy is something defined by how much of a substance you have, what its temperature happens to be. And to change that internal energy, there's really only two things we can do. We can heat the substance, or we can do work on the substance, or the substance can do work on the environment. Those are the only two ways to change this internal energy. And so we can write that down mathematically. We can say that the change in internal energy is going to be equal to heat or work. And we put this negative sign in here because our convention in this class is that if I have an expanding gas, the work is positive, but an expanding gas will cool an object, right? So if I have an expanding gas, we say that work is positive, but that's going to make the internal energy go down. So that's why that negative sign is in there. And that's just a convention that we use because when we're talking about things like heat engines, we like to talk about the work done by the gas because we're usually trying to apply that work to something in the environment. Okay, so every time you perform a process on a gas, you're doing one of these two things. You can think of work as like a mechanical compression or expansion. You can think of heat as either cooling or heating from various processes. And we can describe these things by their impact on pressure and volume. So I can make these things called PV diagrams, where I have volume on this axis and pressure on that axis. And I can say, well, if I'm going to do work, that's going to be equivalent to a change in volume. And the question is, how does that affect the pressure and what are the processes we can do there? So let me just write down a few of the different types of processes you can do. One is you can have what's called a constant volume process, or something known as isochoric. So isochoric is constant volume. And because it's constant volume, there's no work. So that means the work is equal to zero. But since I am changing the internal energy, if I increase the pressure of a gas at a given volume, that's going to increase the temperature. Since I'm increasing the energy, that means that there has to be heat exchange. So the heat is not equal to zero. I can also do isobaric, right? So this is isobaric is constant pressure. And in this case, because the volume is changing, the work is not equal to zero, but neither is the heat. So we can have both heat exchange and work exchange in an isobaric process. And then we also have something called an isothermal. So I'm going to just draw it like this. And that is a constant temperature. And it has this shape like that because PV is equal to NKT, and so the pressure has to be proportional to the inverse of the volume. So that's a 1 over V line there. And that constant pressure, or that constant temperature, is called isothermal. And in that case, the change in internal energy is zero, but work is being done and heat is being done. So those are not equal to zero. And then the last process we can talk about is something called an adiabatic process. And this is by definition when heat is equal to zero. And if I draw another isothermal here, an adiabatic process is one that goes from one isotherm to another along a line that looks like that. And while the heat is equal to zero, there is work being done. And because we are changing from one isotherm to another, the internal energy is also changing. So those are the different ways you can do. You can change the pressure and volume. One is a constant volume. One is a constant pressure. One is a constant temperature, and one is where there's no heat exchange.